Example 1 here, we have f of x is equal to 3 over x plus 2. Now, remember, f of x is the same thing as y. This is just saying a function called f, that's just the name of it, and the variable we're using is x, f of x. So, when we're trying to graph rational functions here, 3 over x plus 2, the first thing you want to look for is your vertical asymptotes. Now, what is a vertical asymptote? You have it in your notes, but a vertical asymptote is any discontinuity and anything that breaks up a graph and creates a vertical line. So, all that really means is it's whatever makes your denominator equal to 0. So we're going to take our denominator, x plus 2, and set it equal to 0 there. So, solve for x. X equals -2, which means we have a vertical asymptote at x equals -2. So you graph this vertical asymptote by just putting a dotted line there at x equals -2. Once you graph your vertical asymptote, now we want to look for our horizontal asymptote. Now, when you have your function in the form of a over x plus h plus k, what we're going to look for is our x minus h, plus k. You want to look for anything that's getting added or subtracted onto your rational function there. Well, there's nothing getting added or subtracted on there, so that means we have a horizontal asymptote. We'll just call that HA at symbol y equals 0. So we have a vertical asymptote at x equals -2 and a horizontal asymptote at y equals 0. So now with these two asymptotes, these are lines that our graph is going to come close to crossing over, but they never will. All right, so let's test that out. Now, in order to test this out, we're going to choose 3 x values to the left of our vertical asymptote and 3 x values to the right. So if I'm going to the left there, I have -3, -4, and -5. So you set up your x and f of x chart. Remember, this is the same thing as just an x and y chart. So x is -3, -4, -5. So now I'm going to take -3 and plug it in. So I have 3 over -3 plus 1, or plus 2. That's strike 1 for me. So now we get 3 over -1, which equals -3 there. So when x equals -3, f of x is equal to -3. Now we're going to try the same thing out when x equals -4. So we have 3 over -4 plus 2. So that is 3 over -2, which is -1.5. And again, if there's any doubt in your mind, you can use your calculator to double check these. And last but not least, we're going to plug in -5, and thanks to the wonders of editing, I already have it plugged in right there. So, -5 plus 2, we end up with 3 over -3, which just becomes -1. So, our values are x, when x is -3, f of x is -3. When x is -4, f of x is -1/2. When x is -5, f of x is -1. And now we're just going to plot our points. So go over to -3, down to -3. At -4, we go down to -1/2. And then at -5, we just go down to -1 right there. And now you'll see it's kind of curving like that. And all of these graphs will have the same general shape and look like that. Kind of like a sideways parabola. All right, So that's the left-hand side. Now let's take a look at the 3x values to the right of our vertical asymptote. So we're going to look to the left of it. We have -1. 0 would be written in right there. 0 and +1. So you have -1, 0, and +1. So I'm going to take -1 and plug it in. I'm going to get 3. I'm going to take 0 and plug it in. I'm going to get +1.5. I'm going to take 1 and plug it in. I'm going to end up with +1. You don't believe me? Type that into your calculator and make sure you do it correctly. So you end up with 1 right there, 1, 1, 0, 1/2, and -1, 3. So it's going to be the same shape of the graph, just mirrored over to the other side there. All right, so that's it for example 1. All right, for example 2 here, we have f of x is equal to 4x plus 2 all over x plus 2. Now with this, still are going to graph this the same way as example 1. We're still going to figure out our vertical asymptote, still going to figure out our horizontal asymptote, choose 3x values to the left of the vertical asymptote, and 3x values to the right of the vertical asymptote. The only thing that's different is for this problem is how we're going to find our vertical asymptote. So before we get to that, or how we're going to find our horizontal asymptote. That's strike 2. So let's figure out our vertical asymptote first. Remember, vertical asymptotes are whatever set your denominator equal to 0. So we're going to have x plus 2 equals 0. Solve for x. X equals -2. Deja vu. So vertical asymptote right there at x equals -2. Now, here we have a binomial over a binomial, a two-termed expression divided by another two-termed expression. When that is the case, this is case number 2 from your notes. Whenever that is the case, you look for your variables and you ask yourself, do my variables have the same exponent? In other words, this is x to the first, that is x to the first. So the answer to that question for this problem is yes. When your variables have the same degree, which just means do they have the same exponent? When your variables have the same exponent, you look at the leading coefficients. Leading coefficients are the numbers in front of your variables with the biggest exponent. When that is the case, all you do is you divide your leading coefficients. So horizontal asymptote is going to be y is equal to 4 over 1. So we have a horizontal asymptote at y equals 4. Right there. Now, set up our chart. So to the left, we're going to have x and f of x. So x is -3, -4, -5. Same values as last time. All right. So I'm going to take -3 and I'm going to plug it in here. So I have 4 times -3 plus 2, all divided by -3 plus 2. So this becomes -12 plus 2 all over -1. -10 over -1 equals +10. So when x equals -3, y, or f of x is 10. All right. Now let's test out -4. 4 times -4 plus 2 all over -4 plus 2. This is -16 plus 2 all over -2. And now that becomes -14 divided by -2, which is just +7. And last but not least, for the left-hand side, we're going to go -5. So we have 4 times -5 plus 2 all over -5 plus 2. So we get -20 plus 2 all over -3, which becomes -18 divided by -3 equals 6. So for this left-hand side, you got nice friendly whole numbers. Remember, that might not always be the case. So it's okay if you get some weird, funky fractions or decimals. Estimate, again, I am not grading you on your accuracy for plotting points. All I care is that you can set up your chart, like this, and then plot the points to the best of your ability. So we're going to go over to -3, up to 10, over to -4, up to 7, over to -5, up to 6, and I'm willing to bet if I were to plug in -6 there, you'd end up with something that'll round off kind of sort of like that. All right. So now, right-hand side, x, f of x, we're going to go -1, 0, and 1 for all the x values to the right of the vertical asymptote there. So take -1, plug it in, end up with 4 times -1 plus 2, all over -1 plus 2, end up with -2 over 1. So that is just -2 there. So now I take 0 and plug it in, and I'm going to end up with 2 over 2 there. You'll end up with 1. Take 1 and plug it in, you get 6 over 3, and that becomes 2. Don't believe me? You could do PEMDAS on your own when you plug in those x values. All right? So -1, we're down at -2 there. For 0, we're at +1. And then for 1, we're up here to 2. So now, it just rounds off like that. That's it for example 2. So for example 3 here, we have 2x plus 3 all over x plus 4. And strike 3 for me. You get absolutely nothing out of it because I'm not in school, so too bad. But this should be x minus 4. So just change that on your worksheets. It's x minus 4 in the denominator. So still start off the same way. Find our vertical asymptote. We have x plus 4 equals 0. Subtract 4 from both sides. X equals -4 there. So now we move on to our horizontal asymptote. And this, because it's x to the first over x to the first, that means you take your leading coefficients. What number's in front of that? This first x right there. What number's in front of that x right there? The numerator is 2. The denominator is 1. So you have a horizontal asymptote at y equals 2. There, and then that should be -4. So change those both to positives. So it's a vertical asymptote at x equals 4. So change that up. Now set up our charts. It's our f of x chart, which again is the same thing as x and y. So we're going to look to the left here. We're going to go 3 and a 2 and a 1. So I take 3 and plug it in. I'm going to have 2 times 3 plus 3 all over 3 minus 4 because we changed it to x minus 4. So now this becomes 6 plus 3 all over -1, which just becomes -9. So now take 2 and plug it in. We have 2 times 2 plus 3 all over 2 minus 4. So this becomes 7 over -2, which is -3.5. And do the same thing for 1 here. 2 times 1 plus 3 all over 1 minus 4. So this becomes 5 over -3, which is -1.66 repeating. And remember, do not just round it off to 1.6 or 1.7. Write -1.66 repeating or -1 2/3. All right? So that way I know you got the right answer and that you're not making up your own math. So now we're going to plot those points and connect our dots. So at 1, we go down -1.66. So a little bit between -1.5 and -2. At 2, we go down to -3.5. That'll be about right there. And for 3, negative 9. When x is equal to 3, negative 9. Because I screwed up on this, it'll be all the way down there. So just connect your dots, and bam, there you go. Now let's try out the right-hand side. So for the right-hand side here, I'm going to test out 5, 6, and 7. So we're going to have 5, 6, 7. I'm going to take 5 and plug it in there. I'm going to have 2. 2 times 5 plus 3 all over 5 minus 4. So this ends up being 13 over 1. So when x is 5, f of x is 13. So let's test it out with 6. We're going to have 2 times 6 plus 3 all over x, or all over 6 minus 4. So up top, you get 15. On the bottom, you get 2. That is 7.5. And last but not least here, let's take 7 and plug it in and see what we get. So we're going to have 2 times 7 plus 3 all over 7 minus 4. So up top, 2 times 7 is 14. 14 plus 3 is 17 all over 3. And that'll be about 6.3 repeating there. So let's plot those points. Obviously, 13 is not on your graph, so estimate 513 will be somewhere up there, off the graph. Then we go 6 to 7.5. So when x equals 6, we go up to 7.5 right there. And then at 7, 6.3 be right about there. So if we were to choose 8, 9, 10, the graph would keep coming down like that. All right, so it's not the prettiest, but still has that same general shape of curving along your asymptotes there. All right, so for number 4, try that out on your own tonight for homework. All right, I'm going to have 2 different Schoology posts for you. I'm going to have one for examples 1, 2, and 3, and then another one that says problem number 4 for homework. All right, both will be graded, and I do not care if you get number 4 right. I just want to see you try it out on your own, see how you do with this.